Hi YouTube. Today I'll be teaching you guys a concept which I found difficult during my midterm and final for organic chemistry, and the topic is drawing perspective molecules as Newman projections and vice versa. So let's get right into it. So on this molecule you can see that it's a cis isomer where both the chlorine and the methyl groups are facing down, whereas a trans molecule would be something like this. This would be a cis isomer, right? So let's get right into the drawing. Since the chlorine is facing down, well, down on the molecule, we can draw it like this on the Newman projection circle. And normally the atoms which are not wedged or dashed will face directly down or directly up, and will be the main focus of the Newman projection, if that makes sense. I'll explain what I mean more when we get into the other side. Since we're looking at it from the left side, the chlorine will, this part of the molecule will be the main focus of the Newman projection, which is why we draw it like this. Whereas the other side, which is the further back side, is going to be drawn like that. Now, before it gets too complicated, I will talk about the front side. So the chlorine faces down, and now we look at the wedge and the dash. If you were to put this in a 3D perspective, the wedge, if you look at it, if you face your head towards some kind of wall and just imagine that being the molecule, how would you imagine the hydrogen and phenyl to be, right? Which one, if it faces outside of the page, or if it's wedged, it's going to face towards you're looking at it from the right side, and you're basically seeing that the hydrogen is facing, the hydrogen should face your left hand, whereas the phenyl should face your right hand. And just like that, your phenyl would go on the right side and your hydrogen should go on the left side. And then we could focus on drawing the other side. Here, again, like I said, the molecule that goes on the top or the bottom will normally be the one on a normal stick, rather than a dash or a wedge bond. So over here you're just going to get a CH3. And since we have hydrogens on both of them, it doesn't really matter where you put them. Very simply, your molecule should look something like, or your Newman projection should look something like this. Now, let's get into an example of how, or let's try to draw this back to its molecule form, right? Since we know that this is a carbon, and this circle around everything is supposed to be a carbon, we can draw it like this. It depends on which way you want to look at it. I'll draw it the opposite way. So we'll face it this way, actually. We'll face it the way it is, right? Since this is the outside carbon, the one with the chlorine part here, since that is the outside carbon, you want to face it whichever direction you really feel like looking at it. I don't mind doing it this way. We can draw it like this. Our chlorine will still go down because it's facing down, and then we'll have a dash bond and a wedge bond for the phenyl and the hydrogen. Now, since the phenyl, if you were to look at it in the perspective of the way it's facing, so we're looking this way now. If you tilt your head to face the right side, and imagine you're looking at the molecule, what do you think you'd see, right? Try to rotate the circles, or try to rotate the Newman projection in a 3D view. What do you think you'd see on the right side, and what do you think you'd see on the left side? So if you were to look at it on your right side, imagine a molecule. Your phenyl right here should be facing the right side. right? And the right side would be the upward bond, and the left side should be your hydrogen. Again, it's just the opposite of this molecule because we're looking at it a different direction. So now if we look at the CH3, the methyl group, the hydrogen and hydrogen, the methyl group should face down as well, or you could face it upward. It doesn't really matter considering your hydrogen, and both these groups are hydrogens anyways. So you could always rotate it and make it look something like this. And you have your phenyl here and your hydrogen here, right? This also works. For the main reason the main reason it works is because both their hydrogens, they're on the same group, right? You don't have a chiral center for it, so it doesn't matter which one faces which side. They're both hydrogens. All right, so on to another question. For this molecule, we can see that we have a trans molecule, one which should face asterisk like this, and we can look at it from the right direction instead this time. Now, we can see that the OH group is gonna be the main focus of our Newman projection. Same with this whole section. That is going to be the outside carbon. That's the carbon you're going to see first when you're looking at it in a 3D perspective. So just quickly get rid of that. Now, since our OH is facing down, we can do that. And now we can draw out our two substituents lines from the main center carbon. And again, if you look at it from a 3D perspective, shift your head to the right, since we're looking at it looking at the molecule from a rightward direction, and you're gonna see that, like, imagine that you have two bonds which are facing one to the right, one to the left, and if you look at it straight, the one to the right is gonna be the one facing out of the page, and the one to the left is gonna be the one facing into the page. So you could draw something like that. Then you have your CH3 over here, which is the back carbon, as this is a back carbon. Your CH3 is going to face the top like normal. And now you have your wedged and dashed groups, which are both CH3s, which you could put down like this. And this would be your Newman projection for this molecule. All right. Thank you, YouTube, for watching this video. Hopefully it's helped you understand how to draw perspective diagrams using Newman projections and vice versa. Please hit the subscribe button if this has helped. Thank you.